You might want a calculator. Or maybe, I don't know, maybe we should do these together. I don't know, what do you guys think? What does this first one mean? I have 4 times, and then it says F with a 3 in parentheses. Like, does anybody know how to do this? You guys remember? What'd you do?
So first I just placed the plus 3, and replaced it with 3 in parentheses 3 times 3 plus 2.
Mm-hmm.
Which then got me to 9 plus 2. So I got me 4 times 9 plus 2, and 4 times 11, and 44.
Awesome. That's all you have to do. So just remember, it's called function notation. So it just means everywhere you see an x in that f of x function, you're just going to replace it with a 3. And why is what I wrote down not showing up on the screen? Forgive. Okay, there we go. I wrote that all down and you guys weren't even able to see it. All right, so I've got 4 times, and then basically right here, exactly what he said, you're just plugging 3 in to that f of x function rule. So want to get that down to one number and then actually multiply it by 4. Perfect. All right, how would you do f of 2 divided by g of 4? What would you do to find f of 2? Don't everyone volunteer at once. What do we think? How would I do f of 2? Go ahead.
Replace it with functions 3 times 2 plus 2 in the numerator, and then the denominator 1/2 4 minus 3, which once you do all that for you get 8 over -1.
Good deal. Okay, 3 times 2 is 6, right? Plus 2 is 8. Just simplify the top and then simplify the bottom to get them down to one number, and then do the division at the end. If you plug in 4 to the g function, that's just the one in the middle there. So you did 1/2 times 4, that would be 2, minus 3 would be -1, and then to actually divide that, we're just going to get -8. Okay, now we're going to try one more. So what would you do to find g of 8? Oh my, you guys are so quiet. Okay, so g of 8, you got the 1/2 x minus 3, right? Everywhere you see an x, just replace it with an 8. Now, what you should do, though, get this down to one number before you do the subtraction, because you just want whatever the g of 8 is. That's your input. This is our output. So 1/2 of 8 would be 4 minus 3 would simplify that down to 1. Now, I'm subtracting h of 2. So this is very tricky. So the h function is -5 times x. So when I do this, I'm subtracting in between here, but I'm going to get -5 times 2 is -10. So what you should actually end up with is a minus a negative. So what does that turn into? Positive. So this really, minus a negative, turns into a plus. So the answer for that last one would be 11. Is anybody having a question? Little function review. All right, linear equation is what we're going to focus on today, and graphing linear equations in a couple different formats. So a linear equation has the word line, right, in the word linear. It's just, linear equation is just the equation of a line. Now, there's a couple different formats. We're going to talk about slope-intercept form, and we're also going to talk about standard form today for graphing. There's a third form called point-slope. We'll talk about that more tomorrow. That's usually used a little bit more in the algebraic way versus actually using it to graph. The ones you typically use to graph are going to be slope-intercept and standard form, so that's what we'll focus on today. But we just have a couple of vocabulary terms, and they're kind of related to what we just did at the top. So I'm going to have a little blank here. It says the blank, and I'm going to write in that blank the independent variable is going to be a variable that provides what we call the input value, also as part of the domain of a function. So I'm going to slide this back down just for a second. So bless you. So when I was telling you, like here, we're going to plug in 3 or 4 or whatever we plugged in, that is the input value, and then what you get is called the output value, but that's also called the dependent variable, which is what the next lovely line says there. Now, that result depends on what you plugged in, so that's why it's called dependent, and this is what we would call an output value. On these questions, the output would have been what we got once we plugged the number into the little function rule. This also corresponds to the range. Do you guys know in general for a linear equation, is it x or y is the independent? What do you think? Y is the independent or the dependent? Dependent. No, you're good. Okay, so in general, and you remember this too, domain goes with x, range goes with y. When you guys usually are presented with an equation, we plug in an x value typically, just like we did on those equations above, and the result is going to be your y value. So in general, like I just have a little example here. This says y equals 3x plus 2. Whatever I plug in for x, that's the independent variable. And then again, y is considered the dependent variable because it depends on what you plug in for the value of x. So you plug in, and you can plug in any x value, and the y value is the corresponding result. Now, the other thing, just real quick, we're going to use today what we call the slope of a non-vertical. So a vertical line, we'll talk about this more tomorrow, a vertical line has no slope, but any other type of line, so non-vertical line, has a slope. It's the ratio, which is a fancy word for fraction, vertical change to the corresponding horizontal change. So if you guys remember, slope, rise over run, the top is the change in your y's over the change in your x. So, do we know the first equation we're going to look at, and if you want to look down to example 1, they're all in this form. Does anybody know the actual, what does the formula look like for slope-intercept form for a line? You guys know which one that is? Do you know? Yes, this one. This one's probably one you guys are, I hope, familiar with. What does the m stand for in that formula? Go ahead. Oh, whoever wants to talk is fine. Don't fight about it. It's the slope. Okay, whatever. All right, thank you. Now, okay, who can raise your hand and tell me what is the b value in that lovely formula? Y-intercept. All right. Now, let me ask you another question. What is the x-coordinate of the y-intercept of any graph? 0. Okay, so this would be 0b would actually be the corresponding point on the graph. All right, I know this maybe sounds a little bit maybe annoying to you, and you already know this, but I always have somebody start on the wrong axis. Okay, so I'm just, don't do this on your paper if you think this is dumb. That's totally fine. I'm going to do it because I always have somebody screw it up. All right, so whenever you're in mx plus b form, the easiest thing to do is look at the equation, start with the y-intercept, but you got to make sure you start on the y-axis. So when you have a graph here, the y-axis is the vertical axis, the x-axis is the horizontal axis. So I'm just going to see if you guys know how to do this. So this says y equals negative x plus 2. Who could describe to me, like, how would you start to graph this? Like, where would you start, and then how would you find another point? Just raise your hand and tell me how you would do it. Where would you put your first point? Where would you put your next point? Like, how would you figure it out? Go ahead.
Start at 0, 2.
Okay. There's your y-intercept. Then what would you?
Then you go down 1 because it's so smooth, and then you go over to the right one.
Perfect. All right. That's always tricky for people. There's a little negative, just a negative symbol, so -1. So I usually just attach the negative to the top of the fraction. That'll tell me to go up or down. And then I know that's weird, but you have the number 1 can be written as a fraction. The number -1 can be written as a fraction. I would just attach the negative to the top. So that tells you up or down. So we're going to go down 1 and then just go over 1. And if you want to repeat that, just, I mean, the more points you have, the more accurate your line is going to be. But technically, you only need 2 points to make a line, play connect the dots. So something like that. So there my slope is -1. You start at 2. All right, very tricky, the next one. Who can tell me, raise your hand, where would you start y equals 3/4 x? Like, where would the y-intercept be there? What do you think? Yes. So, and don't add this in, you don't have to, but there's nothing added to the side of that. So that just means the y-intercept is 0. If you plug in 0 for x, the y-coordinate would be 0, right? So 0, 0 is your y-intercept. Okay, how would you find another point? Perfect, perfect. All right, so you have 3/4. So, like I was telling you on the last one, I attached the negative to the top. You go down and right. If you go this way, this is up and right. I always attach the negative to the rise, and then the run, I always go to the right. So this one is going to have a positive slope. So you're going to go up 3 over 4. And I might be able to get another one in here, but you just need 2 points to play connect the dots to make your line. The more points you have, the more accurate your line will be. Now the last one, sort of tricky because it's not written in slope-intercept form. What would you do to this line? I've got negative 2y equals x plus 6. Like, what would you do maybe to help graph this? Okay, get the y alone by dividing it all by negative 2. All right, that's exactly what I would do. Now, what would your slope be there? I think this is really tricky. What would your slope be? Liam, what do you think? Heck yeah. All right, so the x doesn't have anything in front of it, right? But it exists. So if this ever helps you, just to put a little 1, I'm going to pull that to the side. I got to divide that by negative 2. That means that's going to be my slope. Just put the x next to it. And then actually for that second part, just divide. So 6 divided by negative 2 is negative 3. All right, so I'm going to start down negative 3 on my y-axis, not my x-axis. Okay, now for my slope, I'm just going to go down 1 and right 2. So down 1 to the right 2. Anytime you got a negative slope, it should slope down from left to right. If you got a positive slope, it'll slope up from left to right. Is anybody having a question about graphing in slope-intercept form? Okay, now I don't have any on this page. Does anybody know what the standard form for a linear equation looks like? Do you guys remember this? It's not the like y minus y1 slope times x. That's a different one. We'll do that tomorrow. Does anybody know standard form? It has an A, B, and C in it. Does that sound familiar? I'm very frightened right now. Okay, see, I'm going to write it and you see if you know this. Okay, looks like this. AX plus BY. Do you guys know that one? Okay, I was about to have a heart attack. Okay, now, there is a little tiny rule to this. A, B, and C have to be integers. And that just means no decimals or fractions. Like, it has to be a whole number. So there are situations, we'll do an example on the back in just a second, where you might have to multiply everything by something to clear some fractions. But technically, when you do standard form, it's supposed to be all nice numbers for A, B, and C. They can be positive or negative, but they are not supposed to be fractions or decimals. Okay, now, y-intercept for any graph, not just lines, but for any graph, what you want to do to find it is you're going to set x equal to 0 and solve for y. Would be of the format 0 and then some number. The x-coordinate is always 0 if you're intersecting the y-axis. And I'm going to write a similar argument for x, but switch out the letters. So if you want your x-intercept, you're going to set y equal to 0. We'll talk about this on the back and solve for x. And that will be of the format some number comma 0. So the y value is always 0 if you're crossing the x-axis, and the x value is always 0 if you're crossing the y-axis. And we're going to do that on the back. All right, before we graph, though, I'm going to have you guys take the standard form, or sorry, the slope-intercept form, and just change it up into standard form. So I'm going to transform this equation here. Instead of what I have written, I want it to look in standard form. So I have ax plus by equals c. I'm just going to kind of manipulate. You can have positive or negative a, b, and c values. They just can't be fractions. Does anybody know, like I've got y equals 6x plus 8. How would you manipulate that to just put it in standard form? You would just have to do one step. What do you think? Exactly. Just subtract 6x from both sides. Just like those literal equations, you can't actually combine that with the y. Just put it out in front. The y is positive, right? There's nothing in front of it. And leave it equal to 8. Now, you absolutely do not have to identify this, but I'm just going to show you real quick. So the A value would be -6, the B value would be 1, and the C value would be 8. So as long as those are all integers, you're good to go. You don't have to identify those. I'm just showing you that to make sure we have integers, not fractions. Okay, now the next one, I think perhaps a tiny bit trickier. How would you manipulate y equals -2/3 x plus 5 to be in standard form? Perfect, perfect. Okay, multiply by 2/3 x. Now, add 2/3 x, fired. Okay, 2/3 x plus y equals 5. Now, the only little rule here, you can't have a fraction. All you'd have to do to get rid of the fraction, just multiply everybody by the denominator. All right, so I'm just going to multiply everybody by 3. You have to do it to everything on both sides to make sure you keep the equation balanced. So on the first one, all that's going to do is cancel out the denominator. So that first term should just become 2x. Now 3 times y, so it would be plus 3y, and then 3 times 5 equals 15. And if you guys were given that format and I said, hey, let's go to slope-intercept form, if you solve that algebraically, it should give you back what we had to start with. But you just got to get rid of the fraction if you have one, because that's not technically proper. Is anybody having a question? Okay. Now, there's kind of 2 schools of thought on graphing these, and so I'm going to do one of each, but it's up to you what you want to do. So you can graph using intercepts. I'm going to use the same graph for both. If you want to do intercepts, this is how I always used to teach it when I taught Algebra 1. If I want the x-intercept, do you remember how I told you on the front we were going to make the y value 0? Okay, I don't usually write that out. Here's what I do. If I make the y value 0, if I plug in 0 for y, would you guys be okay with me saying that would just totally wipe that term out? Because if I multiply anything by 0, okay, I always used to just tell people, just cover up the one that you don't want. So if you want the x-intercept, just cover that up. So really the little equation I'm solving would be 5x equals 20, so x would be 4. Now, you don't have to write this, but that would correspond to the point 4, 0, because I put in, when I covered that up, I'm plugging in 0 for y, so that would give me the point 4, 0. Then I just basically repeat that process, but for the y-intercept, that is when x equals 0. So if we plug in 0 for x, that would just wipe out that first term, and all we'd be left with would be 4y equals 20. Divide by 4. Now that would correspond, I covered up the x, so I'm plugging in 0 for x, so the x coordinate would be 5, or sorry, 0, the y coordinate would be 5. Now, remember I told you on the front, you only need 2 points to make a line. So if I come over here, on the x-axis, I would just have a point at 4. On the y-axis, I'd have a point at 5, and we would just play connect the dots. That's graphing using intercepts. So this would be part A here. Now, the other option, and if you like this better, some people just like it better. Some people like to take the standard form and they'll just put it into slope-intercept form because that's easier for them. So if you want to do that, all I'm going to do is get y by itself on one side. So I'm just giving you both options so you have them. So I'm going to subtract 7x real quick. I get -3y, -7x, and just scooch the -21 to the side. When I move a term with a variable to the other side, I always just write it right after the equal sign because it'll look more like slope-intercept form. Just slide that -21 down, and then everybody gets divided by -3. So that way, if you like slope-intercept form better, I am fine with whatever you like. It's probably the same amount of work. So this would be 7/3 x, and then plus 7. All right, so on my graph, this would be a little bit of a challenge to do. So here's 7. I would go up 7 over 3, which I don't really have space to do here. So the other thing you could do is you could go backwards. I'm going to go down 7 and over 3 to the left. So if I go down and left, those are both negative directions, and 2 negatives cancel out to make a positive, which that has a positive slope. So that would be an option. If you had said like, hey, Miss Gordy, I like that intercept better, if you want to do intercepts, do that. Like I just cover up the 3, you'd get 7x equals -21. So the x should cross at -3 on the x-axis, which you guys can see on my graph, if you like intercepts better. Now on this one, if you want to plug in 0 for x, Just don't cover up the negative in front of the 3y. You got to keep that in front of the term. So for the y, you'd have negative 3y equals negative 21. So y would be 7, and you can see that's where my graph crossed the y-axis. So whichever method you like better, that's what I want you to use. Okay, now I'm going to scooch this down. I would recommend to you these last two problems. If you're working with a word problem, I usually don't put it in slope-intercept form. I usually just use the standard form and find the intercepts because it tends to be easier for me to do. So I might recommend that here, but you could transfer this into slope-intercept form if you like that better. So this one says the equation, 3x plus 2y equals 120, standard form, models the number of passengers who can sit on a train where x is the number of adults. So you can see the x-axis is labeled with the number of adults here. And y is the number of children. So you can see the y-axis is labeled with the number of children who can sit on a train. And graph the equation, graph and explain what the x and y intercepts mean. All right, so don't rewrite this, but if this was me, if I want my x-intercept, I'm just going to plug in 0 for y, and I just take care of that by covering it up. So I'd have 3x equals 120. What would x be there? 40. All right, so I'm just going to come here, and I'm just going to put a dot on the 40 on the x-axis. All right, if I want my y-intercept, I'm just going to cover up the x. That's plugging in 0 for x. So I'd have 2y equals 120. What would my y-intercept be? 60. All right, and then all we have to do, if we like that process a little bit better, just play connect the dots. I think it's much easier for a word problem to do it like that. Now, my x-intercept, it's really the point 40, 0, and my y-intercept is really the point 0, 60, right? If I actually wrote the coordinates of the point there, it says explain what they represent. What do the intercepts represent? So if I'm looking at the x-intercept, can you tell me what the point 40, 0, what does that mean in terms of the problem?
When there's 40 adults in the class and they're calculating more than
Exactly. All right, so this just means 40 adults, 0 kids. I'm not writing out the word children. I'm lazy. Okay, what does the y-intercept mean then?
when there's 60.
No adults, right? And 60 kids. Perfect. And that would fit on this train. And then any combination along that line would be number of adults and children that could kind of work together and sit on the train. Those are one variable is all or nothing, and the other variable is 0, is how the intercepts work. Okay, now I have one more equation. I think this one's a little bit weird because I don't have an equation for you. We're going to write it. This says write a linear equation in standard form to model how you can give 40 cents in change if you only have dimes and nickels. And just so we all have the same equation, it says, and don't rewrite this, it's in the directions. It says let x be the number of dimes and y be the number of nickels, is what it's going to represent. How could you give 40 cents in change, different combinations, if you only had dimes and nickels? Anybody have any idea how you would write an equation in standard form that would work for this? Go ahead. Yeah, okay. Okay. Not an equation, but we can actually do the graph apparently before we could even write the equation. That's perfect. Does anybody know what an equation would look like for that? He's exactly right. So this means, right here, this would mean 4 dimes would be 40 cents, right? 0 nickels. And this one would mean no dimes and 8 nickels, and 8 times 5 would give you the 40 cents. How could I write an equation for that in standard form? What do you think? Perfect. Okay. She says 40 equals 10x plus 5y. How come it's not like 0.4 like it was in the problem? You're right. This is right. But I like, how did you know? She just knew. I'm just going to show you this real quick. Okay, so 40 cents. If you did this like a dime would be 10 cents, and a nickel would be 0.05. Don't put 0.5 because that would be a 50-cent piece, and I don't even think those are in circulation. I have some at home, but my grandpa used to give them to me for my birthday. Whatever. All right, now to scooch the decimal, so you're working with nice numbers. The easiest thing to do there, the 40 and the 10 and the 0.05, I need to go over 2 decimal places. If you would just multiply by 100 there, that could convert it to this equation, which is way easier to deal with. But that would be standard form of an equation. 10 cents for every dime plus 5 cents for every nickel has to equal 40 cents, and then we're not messing around with the decimals. Really good. Is anybody having a question? Okay, so I have the homework on the Math Excel for you guys. If anybody forgets their login or anything like that, I can't look up your password, but if you can't remember it, I can reset it, or have you reset it. But if you need a link, it's mathexcel4school.com. Make sure you have the for school in that. Hopefully you bookmarked it. But if anybody's having trouble logging in, let me know. And the assignment should say homework 17A, because it'll match up with the note paper. Bless you. And we got about 12 minutes right now. And hopefully it'll be if anybody needs help with the graphing tool, if you haven't used that, just let me know.